Let's take a look at the Azure Cosmos DB resource model so that you can get a familiarity with all of the different resources you'll be interacting with. Starting from the very top, what we have here is a database account. A database account has a URI and a set of keys with which you can then use to connect an application to your Cosmos DB. To provision an account, you will go to the Azure portal located at portal.azure.com, and on the left-hand nav, you're going to click on New, Databases, Azure Cosmos DB. A blade will appear where you can define the URI for the account, as well as select a starting API, a parent subscription and resource group, and a starting location. Upon clicking Create, the account will be provisioned and a set of keys will be generated for you to access that account. Underneath an account is a set of databases. Databases in Cosmos DB world is a logical construct, and it is very important to note that. They are merely a logical grouping of containers and users. The user and permissions resource model will be used to perform fine-grained access control on the underlying containers and items. Containers are where things get interesting in Cosmos DB because it is the first time physical resources will start to be touched. And the amount of physical resources backing a container is dictated by the amount of storage and throughput that you need. Another interesting attribute of a container is the fact that it can be efficiently projected to a number of different data models depending on the API you are using to connect to Cosmos DB. So for example, if you're connecting to Cosmos DB using the DocumentDB API, then a container will be projected as a collection and the underlying items as documents. To provision a container, you can do so using one of the SDKs or going through the Azure portal. You'll just need to populate a few things, including what is the ID for that container, what is the starting amount of throughput you want to provision for that container, and this will control what is the amount of physical resources that will start for that container with which it can elastically grow and scale on demand. And you will also define a partition key. The partition key is going to be a path to a property within the item, and it's going to instruct the Cosmos DB how to distribute and route queries for that container. You can operate on underlying items. These are the actual records stored in your database, or rather in the container. And these are exposed through a number of CRUD and query operators. Now, depending on the API you are using to access Cosmos DB, you will also be given a set of server-side scripts that you can add on to the container. These take form in the form of stored procedures and triggers for performing multi-record transactions over a set of items, as well as user-defined functions for augmenting the query language. The container also exposes a construct called conflicts. Conflicts are used to resolve, well, conflicts. These are going to be exceptionally rare. However, they are the means for recovering records in the event you have something akin to, let's say, a automatic failover due to a natural disaster that knocks a region offline. Upon when the region recovers, anything that needs to be replicated still will be surfaced through the conflicts feed. This gives you a comprehensive view over all of the various resources with which you can interact with under Azure Cosmos DB. Thank you for watching.